Why do we measure a complete rotation around a circle as being 360 degrees? When you think about it, the number 360 is a bit arbitrary. For instance, it might seem easier for everyone to agree that a complete rotation is 100 degrees, with a right angle being 25 degrees and a half rotation being 50. But that's not the measurement we use. So where did the 360-degree standard come from? The origin comes from the first time that people needed to accurately measure angles, when they looked up to the sky and charted the movement of heavenly bodies. Ancient people all around the world developed various ingenious methods for measuring the movement of the sun, earth, and moon in order to design calendars. The problem with making a calendar is that the rate that the earth rotates to make a day, and the time it takes to orbit the sun to make a year, and the phases of the moon don't all fit together as nice clean pieces. Among the ancient people who faced this challenge were the Babylonians. They created a highly accurate calendar based on the phases of the moon, which last between 29 and 30 days. When they worked to fit these lunar months into a year, they made a system of long and short years, not that different than our current convention of a leap year. To keep things clean and simple, the Babylonians also made an informal, ideal calendar that was made of 12 months lasting 30 days to make a 360-day year. This was also convenient for them because their number system was based on 60. Unlike our numbers today that build on a pattern of 10, the Babylonians built their number system on a pattern of 60. And 360 fit nicely into that pattern. Following this method of breaking a year into 12 pieces, they also broke the length of a day into 12 pieces, called a biru, making their version of an hour. They then broke the 12 biru into 30 pieces called us, making their version of a minute. This gave a total of 360 us in one day, meaning that over the course of a day, the sun took 360 us to make one complete rotation in the sky. In the 2nd century BCE, the Greek astronomer Hipparchus began studying Babylonian astronomy. As he applied further geometric calculations to their work, he started using their divisions by 360 to describe the degrees of rotation around a circle. And that unit has stuck with us through the millennia. However, just because we know how we ended up with 360 doesn't necessarily make it the most convenient solution. The scale of 360 is based on the movement of the sun, earth, and moon, and it might be more useful to base the unit of measurement on the circle itself. If you take the radius of a circle, the distance that radiates out from the center to the outer edge, we could use this as our unit of measurement. We can take the radius length and wrap it around a circle. An angle that opens up to one radius wrapped around the circle can be described as being an angle of 1 radian. The radius simply acts as our measuring stick. Extending on around, we see that a flat angle spans a little more than 3 radii. This quantity is a value we call pi, which is a value that starts with 3.14 and continues on forever. So a 180-degree angle equals pi radians. A complete rotation around a circle extends out a little more than 6 radii, or 2 pi radians. Now, it may seem like we just made this weird and complicated again, since a radian is based on a Greek letter that represents a decimal value that never ends. But the value of pi is intrinsically rooted in how a circle is formed, so it's a natural basis for measurement. When you work with patterns in circles and angles, radians give us an elegant, clean system to work with, which is why it's used extensively in engineering and higher-level math. Just as you can choose to measure length in inches or centimeters, or temperature in Fahrenheit or Celsius, we can measure angles in degrees or radians. And radians give us a clean system of measurement that's based on the nature of a circle.